Okay, this is our second day of the 3.6 notes. All right, as a refresher, what we did last time, I gave you a point, and I gave you 2 points on a different line, and we were trying to find the distance between the line and then that point. All right, so we did this whole long process where we found the equation of the line that went through those 2 points. In this example that I have pulled up, it was -5, 3, 4, -6. Found their slope, found their equation. And then we talked about how the shortest distance from any line to any point is the line perpendicular that passes through that point. So it was like the second step, we found the perpendicular line that went through our point P. Then we figured out where that perpendicular line intersected the other line. We called that point Q, and then we found the distance between those points. Okay, we had started talking about parallel lines. That's what we're going to do today. It's actually a little bit easier. Okay, so if I have 2 parallel lines, and these are the ones from your notes. The first one, -2x plus 4, that's my green one here. You can see it has a y-intercept of 4. And then the purple one, that's the second line listed, that's -2x plus 14. I want to find the distance between these 2 parallel lines. So we talked about how that would just be like the perpendicular kind of line that connects these. And we also mentioned that it could be really at any point, right? And this distance is always going to be the same if these 2 lines are parallel. Okay, so what we're going to do to solve these problems is we're going to pick a point on one of the lines. And the easiest way to do this is to pick the y-intercept. So I'm just going to use my green line because that's my first line here. And I can clearly see the y-intercept is 0, 4. All right, we're going to use this as our point P. Point P. We're going to find the distance from this point to the other line. Okay? And again, I kind of broke it down step by step here. So first, and I'll use my colors here. This one's green. Let's see if I can get a purple up here. Purple. This is my purple one. Okay. So step 1, find a point on one of the 2 given lines. The y-intercept is the easiest. So I'm going to pick the green one. I'm going to pick the y-intercept, which is 0, 4, because that point is on my green line. So then what we're going to do next is we're going to find the line that passes through that point and is perpendicular to the green line. I'm going to find this line. Because I know if it's perpendicular to the green line, it's also going to be perpendicular to the purple line because they're parallel, right? All right, so now I know a point that's on this line, and I can figure out what the slope needs to be. All right, if my green line has a slope of -2, the slope of the perpendicular line to that would be positive opposite reciprocal 1/2. Okay? So we know the slope of the perpendicular line, and we know what point it passes through, 0, 4. Now, this is why picking the y-intercept is the easiest, because we don't need point slope form here, do we? We could jump right to y equals mx plus b form to write the equation of this line, because the point I picked is b, is my y-intercept. So the equation of that perpendicular line is simply y equals 1/2 x plus 4. All right, I'm going to do this on decimals to kind of give us a visual of what we're doing here. I don't know what color they're going to use here, but we have y equals 1/2 x plus 4. Okay, you can see my sketch is a little off. Let's get rid of my sketch. But there's the equation of the line that's perpendicular to the green line, and it passes through that point. All right, now, like before, we're going to figure out where this perpendicular line intersects the other line, so my purple line. Okay, I know it's 4, 6. We're going to do that algebraically. I need to figure out where this line is the same as this purple line. Do you guys remember how we did that? Algebraically. Last time? Anybody? Okay, here's the purple line. Here's the perpendicular line we just found. Anyone remember how we figure out where these meet? Ben?
They equal those points.
Yes, them equal to each other. Good. So I'm going to do, where does the perpendicular line, that's my blue one, where does that meet? My purple line. Now, because a lot of your equations here are perpendicular slopes, you're going to get a lot of fractions. So remember I showed you, you can always just multiply by the LCD, which in this case is just 2. Kind of get rid of your fractions, as long as you do it to both sides. That would give us x plus 8 equals negative 4x plus 28. And it just becomes a little bit easier to solve. We add over the 4x, we get 5x plus 8 equals 28. Subtract 8. Divide by 5, we get x to be 4. And remember, I always call this like point Q. It's a point, so it's an ordered pair. So you need to find both x and y. Anybody remember how we find y? Matthew?
You plug x into one of the equations.
Exactly. If this is on both the lines, it doesn't matter. You just plug x back into one of the equations. I'm just going to use the purple one because there's no fractions there. So I know y is negative 2 times 4 plus 14, which would give me 6. All right, so I just found that those intersected, that perpendicular line and the other line intersected at the point 4, 6. Let's just quick reference back to Desmos. Now, obviously, you have to have work shown for this, but if you guys are like doing your homework and you want to check with Desmos as you go, do it, because if you get all the way to the last step and you're like, oh my gosh, I got the wrong distance, and maybe your mistake was in the first step, that'd be pretty frustrating, right? So you can use Desmos to can help you, and you're like, okay, here's the equation I got. Yep, that looks perpendicular. I got them to intersect at 4, 6. Yes, that looks right. Okay, so now we know a point on the green line, the one we picked, 0, 4. We know this point. We know these are perpendicular, so now I'm just going to find the distance between those 2 points. Here's our distance formula. And if you want to rewrite P and Q, you can. P is 0, 4. That's the point we picked. Q is 4, 6. All right, so I'm just going to finish with finding the distance, which, as a review, is the square root of x2 minus x1 squared plus y2 minus y1 squared. Something we've been doing since chapter 1. All right, so in this case, I would have 4 minus 0 squared plus 6 minus 4 squared. So that'd be 4 squared plus 2 squared. Looking like we're going to get 16 plus 4. All right, you get the square root of 20 as this distance. We want to write our answers 2 ways. 1, simplest radical form. 2, decimal form. So decimal form, you can just square root 20 on your calculator. Simplest radical form, however, whatever method you need to do. I like to do the perfect square, and I see, oh, that's 4 times 5, so that's 2 root 5. As a decimal, I got 4.47 units. Okay. Any questions? A good refresher after coming off a long weekend, huh? All right, now you guys try one with the parallel lines, but I'm going to like baby step you through, okay? Now, oopsie. This next one is a little extra step. What's a little weird about my 2 lines here? One, they're not in slope-intercept form, right? Let's go ahead and put them in slope-intercept form right away. And you can do this under step 1. It doesn't matter. And plus, after I graded that quiz, we need practice with this. Practice solving this one for y, putting that in slope-intercept form. We'll call that one my green one. This one my purple one. All right. While I get these loaded into Desmos, you guys put these in slope-intercept form, okay? Okay, I'd recommend two things. I'd recommend dividing each term by 3 so you can kind of see the algebra here, the math here, and think of this as like a -1 in front. So that's a -1/3 x. 6 divided by 3 just ends up being 2. All right, this one, subtract x. Divided by 3. We again have that setup of -1/3 x, and the y-intercept, just leave it as 14/3. That's fine. All right. Now we can see that these two lines are parallel. Why? You can shout it out. Same slopes, right? These both have a slope of -1/3. Okay. So I plotted those in decimals for you. Here they are. Here's the one with the slope of -14/3. So I'm going to give it as a decimal. Here's the one with the y-intercept of 2. All right, we need to pick a point on one of the lines, and I always like to pick the y-intercept. Which y-intercept would be easier to pick here? The green or the purple? Definitely the green, right? 0, 2. Let's pick that as our point. That's all step 1 is. Pick a point on one of the lines. Y-intercept is always easiest, so we're going to pick 0, 2. Okay. So now what you guys are going to do is you're going to write the equation of the line that contains the point 0, 2, but is perpendicular to the green line. So think about what the slope is. Don't say that loud. Think about what the slope would be. And now you have a point. Write the equation. Give you 1 minute. All right. What would the slope of the perpendicular line be? You can shout it out.
3.
+3. Good. Opposite reciprocal. Slope of 3, passing through 0, 2, which is the y-intercept. You can jump right to y equals mx plus b. Y equals 3x plus 2. There's a perpendicular line. Let's see if Desmos agrees with us. So this is what you can be doing on your homework. See if y equals 3x plus 2 passes through that point we picked 0, 2, and it does look perpendicular. There's no way to tell for sure, but at least it doesn't look, something like this. You're like, ooh, that's definitely not perpendicular. Okay? All right. Next order of business, you're going to find where the red line intersects the purple line. So, I'll write this one in red for the sake of comparison here. Here's the red line, which is the perpendicular line, the one you just found. Purple line is this. All right, you guys need to find the point where they intersect. If you don't know what to do, look back at the last one we did in step 3. Okay, first thing we're going to do is we're going to set them equal to each other to figure out where they meet. I would times both sides by 3 on this one. And get 9x plus 6 equals negative x minus 14. All right, solve this. I got x to be negative 2. If you even want to check that on decimals, come over here. Say, where do they intersect? Oh yeah, the x coordinate is negative 2. Okay, so far we're on the right track. Now we got to find y, so we plug that into one of the original equations. I'd probably do the red one in this case. There's no fractions. Now we know x is negative 2. Negative 6 plus 2 is negative 4. And that was that point at decimals. Negative 2, negative 4. That's usually the hardest step, is finding that point of intersection. Now you have the 2 points. We have P, which we chose earlier, 0, 2. And we have Q, negative 2, negative 4. All right, folks, you know what to do. Find the distance. Give me 1 minute. Okay, I ended up getting the square root of 40. Can somebody give me the simplest radical form for that? Or the decimal. Alex?
2 square root 10.
2 root 10, thank you. Alex, did you get the decimal one too? No. Somebody else decimal? Decimal. Gwen?
6.3.
That's what I got too. 6.32 units. Thank you, ladies. All right, that was the last of the parallel line ones. I like those ones better. They feel a little bit easier because you get to pick a nice point to y-intercept. Same process though, good practice. All right, I just have a couple special cases to go over, things to be aware of when you're doing these problems. Find the distance between the lines. All right, in this first case, I have the line x equals negative 3 and x equals 5. Okay, if you remember how to graph these, you go to your x-axis, you find negative 3. And I want all of the coordinates that have an x value of negative 3. So show me with your arms what type of line that is. Vertical, right? All of these coordinates up here have x values of negative 3, so do these ones. So that ends up forming a vertical line. Vertical line. X equals negative 3. X equals 5. Super similar. Find 5 on your y-axis. Sorry, x-axis. 1, 2, 3, 4, 5. X-axis. Vertical line. So if you have vertical lines and you're asked to find the distance, this just became a lot easier because these are nice and straight, right? These are nice and straight. So my distance between these, I can literally just kind of like subtract or count the boxes here. But my distance would be the difference of where I'm at on my x-axis, 5 minus negative 3. Remember, absolute value for distance, we always have positive distance. So you could also do negative 3 minus 5. But our distance here is 8 units, which you can see nicely because I had you plot these. You count. There are 8 units between the two lines. But if you have x equals, just figure out the difference between where they're located to find the distance. Wow, that was a lot faster than having to do that 4-step process, right? Okay, same with horizontal lines. Y equals negative 1, that's this line right here. Y equals 6, that's here. Whoa, oh no. Oh, I've broken so many pens. That might be okay. All right, just find the difference here. So 6 minus negative 1. That distance would be 7 units. Okay, so don't overthink those ones. Those are a lot easier than having to do the whole long process if you get equations that have just x equals or just y equals. As review, what do these lines have a slope of? Undefined? These ones? 0. Whoa. Oh, that was cool, huh? Put that back. Okay. We're going to do one more of these problems, and I took the training's wheels off. And this one's a little different because they actually give us the equation of the line. All right, so let's read this here. It says, what is the distance from the point negative 6, 5, so it's kind of like my P, and the line whose equation is this? All right, so first thing I want to do is I want to write this in slope-intercept form by solving this for y. And I end up getting x divided by 6. Think of that as 1/6 x plus 6. Okay, so I'm trying to find the distance between this point to the line, and we know that is the perpendicular line, the shortest distance, right? It would be the perpendicular line that goes through point P and is perpendicular to this line. Okay, perpendicular to this line would be opposite, reciprocal, slope of negative 6. Do I need to do point slope form in my next step? Yes, because this is not my y-intercept. So I need to do y minus y1. So right now I'm kind of like on step 2 of these problems of finding the perpendicular line. So y minus 5 equals m, which is negative 6, x minus negative 6, which is plus 6. Okay. There's my point slope form. Let's put this into slope intercept form. Okay, we're here. The green line is perpendicular to my blue line and it goes through that point. What would I do next? After I find the perpendicular line. What's step 3? Have them equal to each other, find where they intersect. Tyson, is that what you're going to say? Mm-hmm. Beautiful. Find where they intersect. Okay, so we're going to take the blue one, set it equal to the green one. Oh my gosh. Poor markers. I would times both sides by 6 here. All right, we get x plus 36 is negative 36x minus 186. All right, I'm going to quickly solve for x, and you'll just see something kind of weird happen. So now I'm kind of finding that point Q where they intersect, and I got x to be negative 6. I'm like, okay, no problem. Plug that in here. Let's find y. 36 minus 31, I get 5. I get point Q to be negative 6, 5. Okay, I'll give you a second to write that down while I talk. Does anyone see what's kind of fishy with this problem? Or notice anything? Tyson.
P and Q are the same.
P and Q are the same point. You're like, what the heck? What do we think that means?
0.
They have a distance of 0. That's exactly what it means. What else? P is on that line, right? P lies on that line. That's why I didn't want to show you decimals. I would have gave away the whole problem, but let's quick just look at that. So the original problem said, what is the distance between this line, negative x plus 6y equals 36, way up there. What's the distance between that line and this point? Oh, it's right on the line. So what's the distance between the point and the line? 0. We went through all the work of finding the perpendicular line, which was negative 6x minus 31. That passed through our point. That still worked. Then we found where they intersected, and Tyson's like, that's the same point. Okay, those are our special cases. That's it. Wasn't that fun? Okay, thanks for watching.